our world is made of atoms, but have you ever seen one? Atoms are so incredibly tiny that they fall beyond the limits of even the best optical instruments. Why? Because the sampling interval of light is way too large. The sampling interval? Let me explain. Imagine you wanted to track the daily cycle of day and night, but you could only look outside once per day at the same time. You would miss that cycle entirely, and if your daily measurements happened during the night, you might even conclude there is no sun at all. The problem here obviously is the sampling interval. Just measuring once per day isn't enough to analyze the day and night cycle. The same principle applies to measurements in space. Any detail too small for your sampling interval will be missed, such as the entire mountain ranges of tiny imperfections that hide on a seemingly smooth surface. For our vision, the defining scale is the wavelength of light. The shortest wavelength we can see is about 380 nanometers. That's still a few thousand times larger than an atom, which is roughly a tenth of a nanometer across. This makes seeing an atom about as impossible as measuring the day and night cycle by looking at the sun once per decade. That changed in 1981, when Gerd Binnig and Heinrich Rohrer invented the Scanning Tunneling Microscope, or STM in short, which doesn't use light at all. The STM exploits the effect of quantum tunneling. It uses an extremely sharp metal tip that is brought very close to a conductive surface. As it gets close enough, about half a nanometer, electrons start to jump across the gap, creating a very tiny but measurable current. The tip scans across the surface, measuring the current. This measurement is extremely sensitive to changes in the distance between tip and surface. So sensitive in fact, that it changes when the tip passes over an individual atom. This way, you can create a map of individual atoms on the surface, which can then be rendered into an image. That's the closest we've come to actually seeing atoms. This breakthrough earned Binnig and Rohrer the 1986 Nobel Prize in Physics. Today, this method is also used to manipulate single atoms by pushing or dragging them. IBM scientists even created the tiniest movie ever by rearranging atoms for each frame. From invisible atoms to an atomic movie, science has moved forward quite a bit.